We're on example number 2 from 6.3. Example number 2, again, is going to be integration by parts. So just to kind of remember what that looks like, if I could take, this is another one of those scenarios where if I can make a function look like this, then I can apply the integration by parts technique. And so we'll do that again with example number 2. All right? So this works for products. So you're going to get a function that's a product. We remember from example number 1 that it was derived from the product rule, and then we just integrated the product rule. And so what I want to do for example number 2, let me write it down, then you'll figure out what I'm talking about. I'm asked to find the antiderivative of x squared e to the x dx. And so the challenge with this is I've got to figure out the antiderivative of this, which is a simple product, which is not easy. But by integrating by parts, what I can do is I can let something be u and something else be du, and then work from there. Actually, not du, dv. So this is dv. It looks like a u, but it's a v. Okay. So I'm going to take and I'll give you a clue. It's got like one of these is going to be u, and one of these is going to be dv. And then we take the antiderivatives and all that business and go from there. So when I choose these, I want to be careful and think about what the here you don't have to be careful, but there are sometimes situations in which choosing u and dv are important. But I'm going to let u be my x squared, and I'm going to let dv be e to the x. And so when I do that, du dx is really just going to be x squared, or 2x, right? And then remember that dx can be tacked on the end. So I could say like du and then tack that dx on the end. Okay, so that's u. And then if I take the antiderivative of e to the x, the antiderivative, somebody remind me what the antiderivative of e to the x is.
Isn't it e to the x?
Yeah. That was a kind of a trick question. So now what I've done is, by integrating by parts, I can solve this by just plugging these values into this formula here. Okay? And so my antiderivative of this is just going to be this uv minus the integral of v du. So u, which is x squared, times v, which is e to the x, right, minus the antiderivative of e to the x times 2x dx. So I'm going to clean this up a little bit. This is still x squared e to the x. I'm going to toss the 2 to the front. And I've got x times e to the x dx. Okay? Now the interesting thing about this, what do you notice about that antiderivative? It's integration by parts again. So in example number 1, we got lucky because we could take the antiderivative of this stuff. But here again, we run into the problem, well, how do I take the antiderivative of that? Well, notice that I have this and this. So I'm still going to use the UV unique. So in other words, to take the antiderivative of this, I'm going to let u be x. Then du would just be 1 dx. I'm going to let dv equal e to the x, and then again, v will be e to the x. So now here's the interesting thing. When I do that, all this stuff stays the same. So in other words, x squared times e to the x minus 2, and then I'm going to plug in that u, v minus the antiderivative of v, or not v, yeah, it's v, v du, oops, alright, v du, okay? So now my new u is x, my new v is e to the x, minus the antiderivative of v, which is e to the x, and then du is just 1 dx, okay? Now I can take the antiderivative of this all day long.
Because it's just
e to the x. So in this particular example, we had to do the integration by parts twice. Now the nice thing about this is it's kind of rigged up. In upper level mathematics, you may need to do the integration by parts 2 or 3 times, but if you keep doing it, eventually you'll get an answer. And so what I'm going to do is, let's finish, we're not quite done yet. So this is e to the x, or x squared times e to the x, minus 2 x e to the x minus e to the x. Okay? Now technically right here is the correct answer, so if you're taking the AP exam and you got to that point, you can just stop. I probably should point out that we're going to tack on the plus c, right? Because they didn't give us an upper or lower boundary, or a limit, and they didn't give us a point on the curve, so it's a family of functions. And I suppose your textbook did this, although it's not required. You could push that 2 through the parentheses, so you'd get negative 2x e to the x plus 2 e to the x plus c. And then that's pretty much it. Any questions on how to do that?